What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.10 or 3.10. Configure and verify redistribution between any routing protocols or routing sources. This is a topic in the CCNP ROUTE exam code 300-101, version 2.0. Let's take a look at the exam blueprint to see where we came from and where we're headed. Alright, so this is the exam blueprint implementing Cisco IP routing. Exam code 300-101 is also known as the CCNP ROUTE exam. Again, make sure you are studying for the most up-to-date material. We just wrapped up the configure and verifying filtering with any protocol. We did a two-part series on that, and today we're going to be configuring and verifying redistribution between any routing protocol or routing sources. After that, we're going to be doing manual and auto summarization in 2 to 3 parts. Because remember, I said I'm going to try to keep these in short, at least under 30 minutes so that we can get in and out. And, I try to stay entertaining and try to stay on topic. See, I'm kind of veering off now. Let's go ahead on with the show. First of all, route redistribution. What is it? When I think about route redistribution, first of all, we're talking about routing protocols when it comes to redistribution, right? We've got EIGRP, we got BGP, we got OSPF, right? We got all these routing protocols. Think of these routing protocols as different languages, right? You got one person or you got somebody in your neighborhood that speak EIGRP, another one that speaks EIGRP. Obviously, they're going to become neighbors because they both speak the same language as far as routers go, right? Now, if we got one router that speaks, you know where I'm headed with this, right? One router that speaks EIGRP and another one that speaks OSPF, they speak in 2 different languages, right? So they're not going to be able to exchange routes, right? That's what the point of these two routing protocols are. Routing protocols, the protocols is essentially rules, right? So essentially they are languages. They're not computer languages like C+ or Java, but they're essentially rules that we use to exchange these routes, right? So when we think about routing protocols, think of them as different languages, right? So let's have a look at these slides real quick. Guess I should have showed y'all this while I was doing this. So yeah, again, think of them as different languages, right? So the solution to getting somebody, let's think about this. Let's bring it back to the real world again, right? You got one person that speaks one language, and you got another one speaking that one language. Obviously, they can try to do some sign language and try to do something that's Neanderthal-like to communicate with each other. But the most efficient way would be to have somebody to translate between the two, right? So think of somebody that's going to be translating between the 2 languages as somebody that's redistributing. Let's head over to the slides and take a look at the official definition. So route redistribution in a router, route redistribution allows a network that uses one routing protocol to route traffic dynamically based on information learned from another routing protocol. Essentially, one language to another. If you look at this topology at the bottom, you got router 3 and a router 2 on the right-hand side, right? In the middle, you've got router 1. Hopefully, router 1, most likely, he'll be able to speak OSPF on the right-hand side, and he can also speak EIGRP on the left-hand side. So think of him as the translator. He's the one that's going to be able to speak information from this person, from this router, router 2, and be able to translate those routes and be like, oh, you want to know how to get to this city? He's going to speak in a different language and tell him how to get to the other city. While running a single routing protocol throughout your entire IP internetwork is desirable, multi-protocol routing is common for a number of reasons, such as company mergers. So you might have another, you might introduce another routing protocol if you bought another company. Like, for example, Google bought, I believe, I can't remember, Google acquired so many companies, they would have to, like, let's say they acquired another company and this other company is running another routing protocol. Well, they're going to need to do some kind of route redistribution for the two domains to be able to exchange routes. Multiple departments managed by multiple network administrators. This is just basically the right hand don't know what the left hand doing. So you're going to have 2 different routing protocols in one company. Or multi-vendor environments. If you just so happen to, you got this department, they've got Juniper devices, or you got this department running Cisco, or you got this department running some other heathen vendor, then you're going to have to use redistribution because they might be using different routing protocols. So we have some requirements when we are doing route redistribution. Again, think of this as the minimum requirements to be able to translate. You can't be able to translate let's say we doing Japanese and French, right? You can't be a translator for somebody that speaks Japanese to French if you don't know Japanese or if you don't know French, right? You need to be able to speak both languages fluently to be able to translate.
Do you understand the words that are coming out of my mouth?
So if we bring it back to this topology right here, router 1 needs to be able to have a working OSPF domain or configuration. He also has to have a working configuration for EIGRP. So he needs to be able to speak both languages fluently to be able to exchange the routes. That's one requirement. I skipped one bullet point. The first one is obviously one working physical link. That's pretty obvious. You got to have at least, that's like saying you got to have a mouth to speak. So that's obviously you got to be able to have a mouth to speak both languages, right? You also have to have the additional redistribution configuration for each routing pro. Basically, you got to have the redistribute command. And I'll show you the command in a little bit. We'll do hands-on in GNS3 and go over that. So this is the basic redistribution syntax. It's real easy, but you just go into router config mode. So whatever routing process it is, let's say router EIGRP, the AS number, or router OSPF, the process number, and then you type in redistribute. You put the source of where you're distributing from. So let's say, for example, this is OSPF, right? You do, let's say we got into config mode for OSPF, right? Router OSPF 1. Again, I'll show y'all an example. You're in OSPF 1, you type in redistribute, and then the other language or routing protocol that you're trying to distribute from, redistribute from. So if we're in OSPF and we're trying to distribute EIGRP routes, and we do redistribute EIGRP, then you got several other options. We'll go into GNS3 and I'll show you what they are. However, okay, it is not that simple though. It is simple as far as the basic syntax, redistribute, and then the source of the routing protocol. But there are some certain rules. It's just like languages. There are certain rules, like for example, French, right, or Spanish even. We know that there's feminine objects, right? Like in Spanish, this table is mesa, right? Mesa is a feminine word, right? English don't have those rules, right? English, we don't say feminine objects. We don't say masculine objects, right? That's one rule that just happens to be in French and English, but it just does not translate in English, right? Same thing with routing protocols. We have what's called metrics. We know what the metrics are, right? Let's break down this syntax right here. The source can be BGP, connected. So we can distribute connected routes. We can distribute static routes, which we've done in the static route video. If you want to take a look at that, go in the CCNP playlist that I have. Metric can specify bandwidth, delay, blah, 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 blah. Match for OSPF routes. Tag, route maps, which we're going to discuss, I believe, in 3.14 or 3.17. Can't remember. I've said that like a couple times in the last video. Seed metric will be kind of like the language rules, so to speak. Redistribute routes are treated differently depending on which routing protocol they are redistributed into. It's just like language translation. Don't get this confused with network address translation now, because I know I'm just using this as an analogy as far as translation and stuff like that. But just think of seed metrics as the language rules, right? On iOS, each routing protocol has its own seed metric, its own rules, just like feminine, masculine in French and Spanish, but they don't have that in English, which is assigned by default to redistributed routes when no metric is configured manually. So you have to define a seed metric. If you take a look at this bottom right, this image right here, right? We've got the OSPF on the left-hand side. It says, hey, I got a route for you. The metric is 66. RIP, what is you know what the maximum hop count for RIP is, right? 15. That's why at the bottom right here, he says 66. I can't even begin to handle that metric, and he faints. 66 hop counts is too much, right? Because the maximum hop count for RIP is 16, right? Or actually it's 15. Anything beyond that, it just won't even show up in this routing table. It'll just drop that route, right? So we have to kind of like, it's kind of like we lying in another language, so to speak. He not gonna know. Because we just making it even more confusing. He just gonna have to take our word for it because he don't know the other language. So that's essentially what we're doing when we're defining the seed metric. We're kind of lying to the other person in another language. It makes it even harder for them. They just gonna have to take our word for it.
Ashino sume hijuni nite kusai.
So let's look at the metrics, right? OSPF, we know it uses cost. EIGRP uses the K values. RIP, like we just said right now, it uses hop count. So if you don't define a seed metric, redistribution is not going to work. Basically, that's what you have to do, is define the seed metric. Again, to configure the seed metric, it's possible to set the default seed metric for EIGRP or routes using this. Basically, you're going to run a config mode default metric, and then you have to, for EIGRP, you got to type in a number for the bandwidth, delay, reliability. Yes, all of them. But you just got to set something that's reasonable. If you know what these are, I'll put a link with the description below. But these are kind of EIGRP basics. You can't redistribute if you don't really know the basics of EIGRP. I think we're gonna do some videos that are basic EIGRP stuff. But again, this is obviously that's a CCNA topic. But those are the metrics for EIGRP. You can also verify the EIGRP redistribution by running show commands. So this is show command, show IP EIGRP topology. You can also obviously do show IP route, and then if the route show up, then you know it worked. If you just run show IP EIGRP topology, redistribute routes will show via redistributed. That's how you'll know. If you do show IP route, it'll just show you the route that it learned it from, but it ain't going to show you the original language, so to speak. So if that make any sense, I'll show y'all when we spin up GNS3. So those are the default seed metrics, right? RIP, the default seed metric is infinity. Obviously, if a route is infinity, it's just not going to show up in the routing table. That's why you have to define the seed metric. Same thing with EIGRP. You have to define the seed metric because the default is infinity. The only thing that takes the original metric is BGP. So as you can see right there, BGP metric is set to IGP. So whatever the original value is, it'll take that seed metric or that metric. And OSPF is the easiest one. It'll set the default metric to 20. So you don't really have to define it, but except for BGP, which is 1. So let's go ahead and spin up GNS3 and do an example of redistribution. We're going to try to do it both ways. And then in part, I think, yeah, we're going to have to split this up in two-part series, maybe 3 parts, but I'm going to try to keep it in 2 parts. Let's move. So this is our topology right here. Pop quiz for y'all. This is y'all pop quiz for the day. We got an EIGRP on the left-hand side. We got RIP on the right-hand side, right? These are 2 different flags. If you know what these flags are, please comment below. Maybe I'll do a giveaway. You should know this, but now I ain't gonna do no giveaway. This is a real easy one. If you know what these are, please put it in the comments below what these flags are. So on the left hand side, we got EIGRP AS number 12, autonomous system number 12, right? We got router 1 in EIGRP. He got a loopback set up, and we've got router 2 in the middle. Obviously, he gonna be the middleman, right? So he gonna speak EIGRP. He gonna speak this language. He gonna also speak RIP, so he speaks 2 languages. Router 2 is the only one that speaks 2 different languages, right? Then we got router 3 on the right-hand side that's in the RIP domain. He only obviously speaks RIP, or Routing Information Protocol, I believe that is, right? So, and this is the 23.0 network, and that's the 12.0 network. We got loopback set up also for router 3, just to advertise another external route. So obviously the configuration, he got to be the one that's going to be able to translate between the 2 languages, right? Router 1, let's go ahead and console in router 1 and see what he knows so far, right? So this is router 1 right here. Let's do a show IP route. Let me kind of minimize that so that y'all can see real quick, right? So he has the 12.0 network, which is connected to him. That's this guy right here, right? He also knows about the 1 network, which is the loopback that's set up to him. This guy right here, loopback 1, right? I believe it's loopback 1, but either way, he knows that route, and it's variably subnetted. So he know about that route. He know about the 23.0 route, which is over here, right? Essentially in another language, but that was EIGRP actually. But he don't know about the 3.0 network. Does he know about it? Let's double check. Nope. He don't know about the 3.0 network, which lies in the RIP domain right here. So we need to figure out a way to learn about this network right here. How we gonna do it? Obviously, redistribution. Well, let's go ahead and router 2. Actually, though, we don't know about the 3.0 network. Let's see what router 3 knows about so far. Actually, no, let's go back to router 2. I'm just so giddy right now, just like the other video. Okay, so obviously we know that we've got router AS12 and an RIP domain. So router 2 knows about those two routing protocols, right? Let's double check though. Show IP protocols. Let's do that to see what kind of protocols we're running, right? Just to verify. He's running EIGRP 12 for these two networks, the 23 and the 12.0 network, right? 12.0, 23 network, right? So he know about those, right? In our EIGRP. So it's kind of like he know about one language. He know about French, and he knows these certain words. He knows these certain dialects, so to speak. And then we also got, he's also running RIP, right? Isn't that pretty cool? He's routing for the 23.0 network. He's not routing for the 3.0 network. But however, he is redistributing for it. I don't know why I ain't set that up. But either way, he's redistributing for RIP. Let's go ahead and see what happens if you just redistribute from this RIP into EIGRP to make sure if he knows it, right? So let's go back to the slide and double check. Do you remember the syntax? Pause it and think about it. All right, we back. So we go to config mode, right? And then we're gonna translate the RIP route into EIGRP, into this domain, right? So we need to go into router EIGRP 12, was it? Yeah, 12. And we are going to redistribute, double check here. So EIGRP, right? So my bad, you can't do that, not that. I'm sorry. You want to redistribute the source. See how I messed up right there? Redistribute and then source, right? So in this case, the source is RIP. So we redistributing RIP, right? Let's run a show command just to verify. Do show IP protocol. And you can see RIP 12 is now redistributing for EIGRP 12 and also RIP, right? Let's go ahead and see router 1 and see if he's learned that route so far. Show IP route. No, he does not know about the 3.0 network, but we showed that he is redistributing for RIP and EIGRP 12, right? You know why he ain't show up? Why the 3.0 route? Why did this route right here not show up? Because we have to define the seed metric. Remember we talked about seed metrics, right? Let's go back and take a look at that. What is the seed metric? Redistributed routes are treated differently depending on which routing protocol they are redistributed into. Each routing protocol has its own seed metric, which is assigned by default. So when no metric is configured manually, we are distributing, or in this case, we are redistributing RIP. And the default metric for that is infinity. That's going to drop. That's not going to show up. So we need to define a seed metric for in this case. Let's go ahead and do that. Let's go back to router 2. We need to define the seed metric for RIP actually. So since we're in, EIGRP. So we're in router EIGRP, right? So we need to define a seed metric for this. Default metric. Now for EIGRP, there's 5 metrics you got to define. In this case, we're going to do bandwidth. Let's do the bandwidth as, let's do 100. The delay metric, let's just do 1. We need to do reliability where value is going to be 0 to 255. Let's just do 255 to make sure it's 100% reliable, as you can see right here. And then another metric is bandwidth. We don't 255 will be 100% loaded. So let's just say 1. We don't want it to be 100% loaded. Maximum transmission unit. Let's go ahead and do 1500 since that's the most common MTU, right? Now we done define default metric. Let's go ahead and show running the router 1 and see if it shows up now. Show IP route. And you can see now we learned about the 3.0 network, right? The D, but notice it says D, right? For EIGRP. How come it didn't say RIP, right? Well, that's because it's kind of like you said, we kind of lied to the router. He thinks he learned EIGRP when really he learned an RIP route. But he does know that it's external. He knows it's some kind of different language. So that's what that's what the EX means. It's an EIGRP route external. But it is the 3.0 network. The metric is 170, which is what the AD is for that's not the metric. I'm sorry, that's the AD for external EIGRP routes, and that's the metric right there. We learned that through the 12.2 route. Let's go ahead and do one more. Let's go ahead and redistribute EIGRP routes into RIP. So we kind of like doing the vice versa. This is what we just did was one-way redistribution. Let's do a two-way redistribution, but it's just one router. In the next video, we'll show you what happens when you have redundant routers doing redistribution. You can introduce loops in that way. It's kind of like spanning tree in a way. So let's go ahead into, let's see what we want to do next. Let's go ahead into router 3. Let's take a look at router 3's routing table. So, actually, you know what? Let's go back and show IP EIGRP topology. That'll show you. See? Now, since we did that, that tells you that it's an EIGRP route and it was for AS12, right? That's the ID number. Here's the route that we learned, right? One successor, FD is 256. So that's one command you also want to learn. Show IP EIGRP topology when you are running redistribution. Let's go ahead and look in the router 3, show IP routes. He obviously knows about the 3.0 network, right? He obviously knows about this loopback, but he don't know about that loopback address right there, right? He knows about the 23.0 network, obviously. That's this disconnected route. He don't even know about the 12.0 network. That's EIGRP. So let's go ahead and redistribute EIGRP route in here. So what we're going to do is we need to go to router 2 since he's the one that translates, right? He's the translator. He's going to have to translate EIGRP routes into RIP for router 3 to understand them. Let's exit out of that just to make sure. Router RIP. So now we need to redistribute EIGRP routes. So that's the source, right? So remember, go in the routing process, redistribute what you want to know. That's my lab every day calendar. I mean, I needed to wake up. That's how early it is this morning. So we are redistributing EIGRP, but we need to define the process. This is different in EIGRP. You define the AS number in this case. So redistribute EIGRP 12. Obviously, we know we need to do the default seed metric. So we know it's not going to work, but I'll show you anyway, right? So show IP route. We still don't know about that other route, right? So now let's do default metric. We need to define a default metric for EIGRP, but we're in the routing process for RIP, so we need to define the RIP metric. In this case, let's say, what's the metric for RIP? Think about that one. It's hop counts. It's hop counts, right? Maximum is 15 hop counts. Let's just lie to this router and say any RIP routes you learn, they're 5 hop counts. So we're saying the default metric is 5. I almost typed 56 there. So now we're saying the default metric is 5 hop counts. That's what we're saying. We lying essentially to router 3. Let's go ahead and log into router 3, this guy right here, and run that same show IP route command. Check his routing table. Show IP route. And you can see he now learned about the 1.0 network, which is basically over here. So now he know about, basically it's kind of like he know another language. Not really another language, a whole language, but it's like he learned a word or two, right? The AD is 120, obviously, for RIP. See, this is notice it says R. This is an RIP route. The RIP AD is 120. And the hop count, we lied to him and said the hop count is 5. That's what we did there. And he learned it via the 23.0, 23.1 interface. So again, if you know these two flags, go ahead and put in a comment below. Let's recap. You have to have an ASBR. What that stand for? You know what that stand for, right? Autonomous System Boundary Router. You have to have a router in both routing domains. Basically, somebody that know how to speak this language and this language and be able to translate between the two. Define the default seed metric, and then you want to apply the redistribute command. Remember, you can't just redistribute. It's not just going to work that way. So if you like this video, please comment, like, subscribe to the network. Don't forget to hit that notification bell next to the subscribe button. That way you know when these new videos are coming out.